Well, we have another question here. Question 5.1 says P and S are points on the Cartesian plane as shown in the diagram below. POS equal to theta and OS is equal to 6. Now the question says determine without using a calculator the value of tan theta and sine negative theta and A. Okay, I'm gonna write the question here, 5.1. Now I want you to pay attention to something. Okay, if you look at the point P here, it has these coordinates negative square root 7 and 3. Okay, so this is the x coordinates and that's the y coordinate, and of course the angle theta is over here on this other side of the triangle formed by the coordinate of the points here. And I know that therefore this angle that we see over here, okay, will be then the angle 180 minus theta, because angle on the straight line makes 180 degrees. So this angle must be 180 minus theta. Now, if I want to keep, okay, use the triangle keeping the values of roots, okay, the values of the points P, the coordinates of the point P, I can draw this triangle over here, and then keeping the signs of the coordinate of the point P, negative root 7 and then 3 like that. Then this angle will be as good as angle theta. Okay, instead of me writing angle 180 minus theta, I can just write angle theta over here. And then I said the adjacent side, okay, is negative root 7 and the opposite side is 3. And then I always prefer to work out all the sides of all the values of the sides of the triangles before start answering the question. So we don't know what is this side, the hypotenuse. Now from the Pythagorean theorem, we know that r squared is equal to x squared plus y squared. Okay, where r is just the hypotenuse, okay, the longer side of the triangle, and then x is the adjacent side, and then y is the opposite side of the opposite side in the triangle, opposite to the angle. So opposite. So this is opposite, and that side is adjacent to the angle. Now let's substitute and calculate the value of r. So r squared will be then a negative root 7 to the power of 2 plus 3 to the power of 2. And then this makes r squared equal to 7 plus 9. Now that makes r squared equal to 16. And then if I need to work out the value of r, okay, what I can do is to square root both sides. Okay, I'm going to square root here and square root there. And then this will make r will be equal to plus minus 4. Of course, this is r is going to be plus minus 4, but r must always be positive. Okay, so we're going to take r equal to 4. R must be positive always. The hypotenuse is positive, so we're going to take 4. Then we can start answering the questions now. 5.1.1, we want tan of the angle theta. Okay, from the trig formula functions, okay, tan theta is equal to y over x. Okay, and then y here is the opposite side, opposite to the angle, and then x is the adjacent side. Now, as said earlier, now we can say tan theta will be then opposite is 3, as we can see there. Opposite the angle, 3 units, over adjacent to the angle is negative root 7. So 3 over negative root 7. So this can be written as tan equal to negative 3 over root 7. We can move the negative sign from the denominator and then put it there on the fraction line. Okay, that's the value of tan theta. Tan theta. All right. We can also some people would like to rationalize this. So if you rationalize this answer, this will be negative 3 root 7 over 7. But it's not like something that we must do in this paper. So we can just stop here, it's fine. Okay, now the following question is 5.1.2 that says the values of sine negative theta. Okay, I'm gonna move my board over here. I need to see the triangle, so I keep it by there. Okay, so I have 5.1.2. So I need to find the value of sine of negative theta. What's that? All right. We have some trig formulas here. Sine of negative theta is equivalent to negative sine theta. Okay, and then sine of theta is equal to opposite side over hypotenuse. Then y over r. So as I just want to say opposite and then hypotenuse. Now, because we have like sine of negative theta there, this will be equal to negative sine theta. Okay. And then negative sine theta will be opposite over y over r. Y is 3 and then r is 4. So therefore, sine of negative theta is just equal to negative 3 over 4. So that's the answer. Okay. And then the following question is question 5.1.3. Right here, 5.1.3. So over here, we were just looking for the value of A. Okay. So in the previous videos, we did 5.1.1, this, and now we're going to do 5.1.3. So we're looking for the value of A. If I look at the triangle here, also, we have this triangle formed. Okay, from the point S, we can form another triangle using the coordinate of S. So they are this. Okay, remember, I cannot take this. I cannot take this as the base. I cannot take y as the base. Take x the base, okay, of the triangle. So now, the coordinates of S are A units there, and then B units over here. So we have this triangle formed. But now look at the angle of this point OS. So the angle is theta over here, another theta there. So we have like two thetas. So to work out, I'm gonna redraw the same triangle over here. So the triangle is like so the triangle is something like this. Okay, so just I'm gonna do it over here just for sake of illustration, and then the angle here will be 2 theta then, and then this side is A, and that is B. Okay, B unit. Now, if I need to find A, when you look at the value, this side A is adjacent to the angle theta. So if I need to find A, I will see, okay, if this side is adjacent to the angle theta, we know that cos of the angle is adjacent over hypotenuse, and then hypotenuse was given to be 6. So I want to say cos. From the formula, we know that cos of the angle is equal to adjacent over hypotenuse, so x over r. Okay, this is adjacent, and then that's hypotenuse. Then in this situation, we have like 2 theta, cos of 2 theta equal to x over x is A. So we have like A over the hypotenuse, which is 6 units. Now, to solve this, what I can do is like hypotenuse here, cos of 2 theta is over 1 there. So what I can do in this situation, we can just cross multiply. So we're going to take this times 6, and then 1 here times A. So 1 times A, that makes A, okay? And then that makes 6 cos to theta. Okay, so we have like A equal to 6 cos to theta. Now, how can I do that? We know one of the 3 formulas says this for cos, because cos 2 theta is a double angle, okay? So that 2 theta will be equal to cos of 2 theta is equivalent to cos squared theta minus sin squared theta, okay? Or it can be 2 cos squared theta minus 1, or 1 minus sin squared theta. Right, then we can select any of these formulas, any of these formulas that we derived from the double angle. Let's take the first one, for instance. This will be A will be equal to 6. So instead of me writing cos to theta, I can substitute by the values of cos to theta. Cos to theta is cos squared theta minus sin squared theta. Then A will then be equal to 6. Previously, we can use, okay, previously we worked out the values of what was the value of theta. Okay, in this triangle here, we can find what is cos squared, cos theta. We say cos theta is like opposite over, x over r, okay, adjacent over hypotenuse. So we're gonna take negative square root of 7 over 4. That should be the value of cos theta. Okay, we can substitute there. That's going to be adjacent negative root 7 over hypotenuse, which is 4. Now that's to the power of 2. I need to write it properly. So I'm going to say, I'm going to use square brackets here. So I'm going to say that to the power of 2. So I sub in the values of that makes negative root 7 over 4. Okay, minus sin squared theta. I sub in sin squared theta. If I look at my diagram over here, is sin of the angle is opposite over hypotenuse. So 3/4. Actually, we did solve it somewhere there over here. 3 over 4. So opposite of the angle over hypotenuse 4. So this will be 3 over 4. So this will be then, this would make A will be equal to 6. I'm going to open brackets here. That make 7 over 16 minus 9 over 16. And then we can work out the values of the value of A. Let's just make say that A will be equal to, okay, when the denominator are common, we can just work out solve the numerator. Okay, so this will be 7 minus 7 minus 9 is negative 2, so that makes negative 2 over 16. Okay, times 6 obviously. So A will be equal to, we can simplify here, or we can use a calculator. So I can just simplify 2 with that. That's like we're left with 8, and then 1 there, and then we can also take out 2, and then 2 again. We are left with 4. Okay, that's going to be 3. By 2 is going to be 3, and then by 2 is going to be 4. So the answer we are just A has the value of 3 times negative 1. That makes negative 3 over 4. That's the value of A. Okay, I'm pretty sure if you check with the other formula, is going to get the same answer. Let's check. Even if I use, because over here I did work out the first formula. Now let's take the second formula. If we sub the A will be equal to 6 open brackets 2 cos squared theta minus 1. Okay, and then that will be 6 open brackets 2 cos of the angle. Okay, cos of I prefer to use the square brackets over here, so I'm gonna say 6 square brackets and then 2, and then that's squared minus 1. okay? Cos of theta, if you look there in the diagram, it was cos of theta, it will be adjacent, okay, over hypotenuse, so negative root 7 over 4. So in this situation, it will be negative root 7 over 4. And then this will make A will be equal to 6, 2, that makes 7 over 16, okay, minus 1. A will be equal to, okay, if you times here, we can simplify this and that, that makes 8, and then you're left with 1. And then we can also simplify there by 2, so that's 3, and then 4. And then, oh, we cannot do that yet, sorry. We simplify this and that, so this will be 6 square brackets here, that makes 1 plus, that makes 7 over 8 minus 1, okay. So if we work out to simplify this also, that makes 7 over 8 minus 1 is something as 8 over 8, okay. And then this will make 6 times 7 over 8 minus 8 over 8, just 1 over 8, negative 1 over 8. Because the denominator are common, we can just work out the numerator. And then this makes negative 6 over 8, which is negative 3 over 4. So the same answer we get here. Okay, same thing will happen if you use 1 sine squared theta. Check it out, that's for you. You're gonna get the same answer. Thank you.